A new study lists the ways a rogue star could spell doom for our solar system. Stars are gravitationally fastened to their galaxies and move in concert with their surroundings. But sometimes something breaks the bond. If a star gets too close to a supermassive black hole, for example, the black hole can expel it into space as a rogue star. What would happen to Earth if one of these stellar interlopers got too close to us? It's not a very likely occurrence, but the chance is not zero. After several billion years, our solar system has evolved into sedentary predictability. The planets move as they move, and the sun sits solidly in the middle of it all. But if another star came too close to us, the invisible gravitational bonds that keep everything going the way it is would be stretched to or broken. Earth is a tiny planet containing only about 3/millionths the mass of the sun. Our planet exists at the whims of the sun and its powerful gravity, and if another star shoulders its way into our tidy arrangements, Earth will entirely at the mercy of the mercy of the new gravitational paradigm. A new paper examines what would happen if a rogue star comes to within 100 AU of our sun. 1 AU, as we know, is 93 million miles. It's the distance between the sun and our Earth. The paper's title is Future Trajectories of the Solar System, Dynamical Simulations of Stellar Encounters within 100 AU. It'll be published in monthly notices of the Royal Astronomical Society. The lead author is Sean Raymond, an astronomer at the Laboratoire d'Astrophysique de Bordeaux of France. And we know that the stable predictability in our solar system will not last. The sun will continue to evolve, and over the next billion years will become more luminous. Earth is awfully close to the inner edge of the habitable zone, only a little closer to the sun, and the delicate balance that allows liquid water to persist on our surface will be disrupted. In that same 1 billion year range, there's about a 1% chance for an encounter with a rogue star. What will happen to Earth if that happens? Will Earth be nudged out of the habitable zone? Earth is about 1 billion years of habitable surface conditions remaining, the authors write. That's in a closed system, which for the most part our solar system is. While the orbital evolution of planets is largely determined by secular and resonant perturbations, the authors explain, passing stars can have a consequential influence on the planet's orbits, obviously. If a passing star comes too close, then our solar system is no longer a closed system. Most rogue stars, also called intergalactic stars or hypervelocity stars, because their trajectories will take them out of the Milky Way, come nowhere near Earth. Kappa Cassiopeia, for example, is 4,000 light years away and will never approach. Others, like the 675 rogue stars astronomers at Vanderbilt University discovered in 2012, were ejected after tangling with the Milky Way supermassive black hole, and their trajectories brought them nowhere near Earth. Even in the Milky Way, space is mostly empty, and most stellar flybys will never approach another solar system. Statistically speaking, flybys closer than 100 AU, which would strongly affect the planet's orbits, only take place roughly once per 100 GYR in the current galactic neighborhood, the researcher said. Though the odds are low, it's a possibility. When you look at the galaxy as a whole, it's almost certain that a stellar flyby sometime, somewhere in the galaxy, will come within 100 AU of another star. If that star is our sun, what will happen to Earth? The term performed N-body simulations is to try to determine the potential outcomes for Earth. They started with the solar system's 8 planets and added a single rogue star. They matched the masses of the simulated rogue stars to the masses of stars in our stellar neighborhood. They also matched the rogue stars' velocities to the neighborhood, and they simulated different velocities and trajectories for the star to see what the range of outcomes for Earth looks like. In total, the researchers ran 12,000 simulations. If a star passes within 100 AU of our Sun, there is still a very high chance that all 8 solar system planets will survive, the authors write. There's over a 95% chance that no planet will be lost. The angular momentum deficit, AMD, as a result of the flyby, largely determines what happens next. AMD is a measure of a planetary system orbital excitation and its long-term stability. It's the difference between an idealized system with the same planets of the real system orbiting at the same semi-major axis from the star on circular and polar orbits, and the norm of the angular momentum of the real planetary system according to this definition. But what does it look like when one of our solar system's planets is lost? The simulation produced diverse outcomes. Mercury is the most vulnerable and is sometimes lost when it collides with the Sun. Other results include Earth colliding with Venus, ejection of the ice giants Uranus and Neptune, only Earth and Jupiter surviving, or only Jupiter surviving. In one apocalyptic outcome, all 8 planets are ejected. Can you imagine? Other results are less dramatic. All 8 planets are unperturbed, all 8 are slightly perturbed, or all 8 are highly perturbed. Though all 8 planets survive in most of the simulations, survival can mean different things. Even though they remain in the solar system and remain gravitationally bound to the Sun, their orbits can be widely disrupted. Some can even be shoved way out into the Oort cloud. The researchers also tabulated the 10 most likely outcomes where planets are destroyed. We determined the most common pathways through which planets may be lost, keeping in mind that there is a greater than or equal to 95% chance that no planet will be lost if the star passes within 100 AU. They write, Mercury collides with the Sun, probably 2.54%. Mars collides with the Sun, probability 1.21%. Venus impacts another planet, 1.17%. Uranus is ejected, 1.06%. Neptune is ejected, 0.81%. Mercury impacts another planet, 0.8%. Earth impacts another planet, 0.48%. Saturn is ejected, 0.32%. Mars impacts another planet, 0.27%. Earth collides with the Sun, 0.24%. When it comes to ejected planets, Uranus and Neptune face the worst odds. That's not surprising since they're furthest from the Sun and most weakly bound to its gravitational pull. It's also not surprising that Mercury has the highest odds of colliding with the Sun. As the least massive planet, it faces a greater risk of perturbation due to stellar flyby. When it comes to our Earth, there are a wide variety of potential outcomes. In the list above, Earth has a 0.48% chance of colliding with another planet. But another potential fate awaits Earth, and it's not pleasant to contemplate banishment into the Oort cloud. The long-term survival of Earth in the Oort cloud is not guaranteed, the authors deadpanned. Another exotic outcome of the simulation is worth considering. Earth's capture by the passing star. That simulation had a star slightly less massive than our Sun and traveling at a relatively low speed, approaching our solar system closely. The outcome was a devastating annihilation of the solar system as we know it. Earth abandoned the Sun and ran off with the star, with 6 of the other planets crashing into the Sun. The lone surviving planet was Jupiter. No surprise there since it's the most massive planet. The paper represents a wide range of outcomes, including the Moon impacting Earth, both the Earth and Moon being captured by the passing star, and even all of the planets and their moons being destroyed, but the odds of any of this happening are extremely low. But how likely is it that Earth would remain habitable in such an encounter? If Earth's orbit is changed, then the planet will be warmer or cooler as a result. There are yet more potential fates. Earth could survive as a rogue planet for 1 million years or so until the surface froze over, or maybe if it did get captured by the rogue star, it would somehow be habitable in some new arrangement. Ultimately, the odds of a 100 AU stellar flyby are infinitesimally small, and the simulations show that if it did happen, the most likely outcome by far is that all 8 planets survive, albeit in orbits slightly different than the ones they follow now. Despite the diversity of potential evolutionary pathways, the odds are high that our solar system's current situation will not change, the authors conclude. And this was originally published in Universe Today, and this is on Science Alert. Please leave your comments. Thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.